Store A sells raspberry for $5.5 per pint and blackberry for $3 per pint. Store B sells raspberry for 6.5 per pint and blackberries for $8 per pint. A certain purchase of raspberry and blackberry would cost $37 at store A and $66 at store B. How many pints of blackberries are in this purchase? Now, whenever we have a question like this one, the first thing we want to do is coming up with some formula, some equation probably that allow us to solve it by using this simple equation method, so an algebraic method. The fact here that they're talking about two different stores make me think that we're gonna solve it for two incognitas by having two equation. Indeed, I believe the two equation are the one that I have underlined in the red, and the one that I have underlined in blue. For example, if we say that raspberries are the letters R, right? Those are raspberry. And the blackberry are going to be the letter B, B for blackberry. Okay. Now, the first equation, the first sentence could be rewrite as 5.5 multiplying by R plus 3 multiplied by B would be the proper cost, or the cost that you would have if you buy raspberry and blackberry by the pint in this store. But this is not an equation at this point, right? At this moment, we don't have an equation because the equation come up when on the third sentence, we know that someone does a purchase and that purchase on store A would be of $37. Now, what I wrote right here is an expression that represents dollars, because these numbers right here are rate. Indeed, we know that we spent $5.5 per pint every time we buy a certain amount of raspberry, and $3 per pint every time we buy some blackberry. So this multiplication right here eventually will give us dollars. Specifically, in the consideration that we are making of this problem, the amount will be $37. Like this, we wrote the first equation. The second equation that is related with store B would say that we spend $6.5 per raspberry and we would spend $8 for blackberry. And in the hypothetical purchase that we were discussing before, that would be $66. Here we're talking about the same amount, right? So there is a relationship between these two equations. What's happening here is that we have two equations with two variables that have some relationship, and that means that we can solve it by using the classic methods for system of equation. For that, I will leave the video, will leave you the link of the video somewhere here. How do we solve it at this point? Well, I'm going to show you two methods to solve this one. The first method is a typical method, is the algebraic method. Whenever we solve it with an algebraic method, we could do something like elimination, substitution, or confrontation. Right now, I'm going to use substitution. And to use substitution, what we have to do is to first take one of the equation and put it equal to one letter. For example, I'm going to take the first one, the one in red, and I'm going to isolate the value of R. The reason why I'm going to isolate the value of R is because of what we need to find. We need to find the blackberries. So I'm going to focus my research on finding blackberries, right? So you will see what I mean in 1 second. But for the moment, I want to isolate my R. That means that I'm going to move the 3b on the other side, and that will give us negative 3b. So we have 37 minus 3b. And I'm going to divide by 5.5 both sides, which means that this one is going to be divided by 5.5. At this moment, what I have is an equation that says that R is equal to 37 minus 3B over 5.5. So whether I say this expression or R, I'm saying the same thing. That's important because now what I will do is take the second equation, but instead of writing R, I'm going to rewrite the expression that represents R. And now by doing that, I have an equation that can be solved for B because it's the only variable that we have at this point. And that's exactly what I will do. I will solve it for B. How do I do it? First, simplification. I need to multiply the internal expression by 6.5. To do that, I will do something. I will split those equations because that's something that we can do, right? I can say, okay, now the denominator 5.5 is going to be here and right here. And now we have two fraction, both with the denominator 5.5. So I'm literally not changing anything, but I'm simplifying now my work because now I need to multiply 6.5 by this fraction, and that will be 37 over 5.5 multiplied by 6.5. I'm just using my calculator to do that one. My calculator leave me a result that is in fraction. And at this moment, I want to leave everything in form of fraction, if I can. So 481 over 5.5. And then minus, now I multiply 3b over 5.5 by 6.5. And that one will be 39 over 11 B plus 8B equal 66. I've simplified my equation. I've done all the operation that were involved at this point. Now what I have to do is bring in everything that is a variable in one side, and in this case we already have it, and everything that is a constant, so it doesn't have any variable in the other side, which is in this case, this fraction, this weird fraction that I'm sure I didn't write it properly, sorry. This one is not 5.5, this is 11. Sorry about that. So 481 divided by 11, it's a constant, which we can move it on the other side. And when I move it in the other side, now I've left this operation. The first operation, actually, I'm going to write it below, is going to be negative 39 over 11 plus 8. Negative 39, 8 minus negative 39 over 11 will give me 49 over 11 B. Now, 481 over 11 becomes negative in the other side. So we have 66 minus 481 over 11. And that will give us 245 over 11. I've just done the operation, okay? I've skipped the part to write them, but I hope it's clear at this point. Because now what we have to do? Now we need simply to isolate our B. And to do that, I decide to multiply by the reciprocal of 49 over 11. Why I want to multiply by the reciprocal? Because when I multiply a number with its reciprocal, what I obtain is going to be the same, it's going to be 1. 11 divided by 11 will go away. 49 divided by 49 is going to go away. So now I have 249 over 11 and multiply 11 over 49. The result of all this operation will be 5. 5 is the answer. If you go back to the multiple choice, we see that 5 was one of the answers. I was telling you, though, that this was one of the methods. And to be honest with you, this is not even the fastest method that you can use for the SAT. Look, this is the method that you would use at school for your professor. Your professor wants to see all the steps, if you understand the process. So you need to show all these process right here. But on the SAT, let's not forget that we always have the Desmos calculator. Now, on Bluebook, you will have the Desmos calculator. Right now, I'm using the browser calculator, but it's the same thing. So what you can do right here? Well, what you can do is write in the equation. Now, what I'm going to do is this. I'm going to write the equation as they are. So 5.5 R plus 3B equal 37. And that's my first equation. The second equation is going to be 6.5 R plus 8B equals 66. At the end of the day, we were solving a system of two equations. The equation have two variables. Whenever we have two variables, they can represent two lines. Indeed, as you can see here, what I've done in the Desmos is representing R as the value of X and B as the value of Y. It doesn't matter if you do the switcheroo. You will find in both cases the same values, okay? The important thing is that you know which one is R and which one is B. That's why for this case, I decide to write specifically the value, because now, whenever you have two lines, you will have probably a point in common. That's one of the cases. And whenever you have a point in common, you in Desmos, you just click a couple of times and you find the two values. And as you can see, my X value is going to be 4, my Y value is going to be 5. We know by definition that, by the definition that we decide, we know that the Y value represents the blackberry, the Y value. And we find out that the Y value for the point that we have in common is 5. That's why the answer is 5. So look at this. A question that took us, I don't know how many minutes, like 8 minutes to solve it by using the classic method of substitution. And you could have used also the other method. Everyone would work, but they would take time to do it. Instead, all we have to do at this point is actually graph the two lines on the Desmos calculator. Of course, that means that now the tough part is not solving it, the system, but is coming up with the two equations. And that's the hard part of this exercise. So to improve on this part, all you have to do right now is learn these new terms, understand when they talk about variables, understand when they give you other hint, like in this case, the rate, so you understand what each calculation can give you, and then work out every time some formulas. Also, I highly recommend you that you practice. If you practice, you will end up understanding this question even better. I hope this quick explanation, I hope this explanation helped you understand this question. If you have any questions, feel free to contact me. Thank you for watching. Bye.